So in 9.6, we're going to look at the quadratic formula. So you see that below. It is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now we use this formula when all of our other methods won't work. So for instance, if I were to graph an equation such as, x squared plus 6x minus 3, maybe, and I don't even know what that graph looks like off the top of my head, but let's just assume that it doesn't hit the graph perfectly. It might hit in between two numbers, and then I'm forced to estimate. And as a mathematician, I want to be as accurate as possible. So graphing is not, in this case, a good method. Another example could be, if I have, let's do x squared plus 7 is equal to, actually, let's make that minus 7 is equal to 42. Now in this case, the square rooting method works really well. I'd add 7 to both sides, and I'd get x squared is equal to 49, and then I would square root both sides, and I would get my two answers, which would be positive or negative 7. So that's a great method if I don't have a b value, meaning, what if I had something like x squared, let's do plus 8x plus 16. So this one I know will factor into x plus 4 and x plus 4, because factors of 16 that add up to 8 would be 4 and 4. Then I would take each expression involving a variable and I would set it equal to 0. Now luckily they're the same thing, so I really almost have to do it once, and I would subtract 4 to both sides, and here I get, x equals 4. But what happens if I get something that's not factorable? So if I have a b value, that means I cannot do the square root method, which means I cannot do the graphing because it could hit, at an imperfect part of the graph, so I have to resort to this quadratic formula. And you'll see that here in your notes. So you want to memorize that. And it does state that a cannot equal 0, which makes sense, because if a were 0, I wouldn't have a quadratic equation. So looking at a, I always start by just writing the formula, because the more I write it, the more I'm going to memorize it. So I write opposite b plus or minus square root, not 4, what am I thinking? B squared minus 4ac all over 2a. Okay, so now that I have the formula, I look at my problem and I see that it's not in standard form. I need to get this set equal to 0, so I see that I've got this negative 20. If I just add it to both sides, it'll move it to the other side. And so then I get x squared minus 12x plus 20 is equal to 0. And remember, a is your coefficient in front of x squared, b is your coefficient in front of x, and c is your constant. So now it's just a matter of plugging in our numbers. So I take the opposite of b, so that makes it just 12. I don't have b in there. Plus or minus the square root of, and then I'll do b squared, or 12 squared, minus 4 times my a value, which is 1, and c is 20. So I got all of these numbers from the equation, and that whole thing is being divided by 2 times my a value, which is 1. So there's a lot going on, so I always advise that my students go slow in simplifying this. So let's reduce everything that's on the inside of the radical symbol. I know that 12 squared is 144, and then 4 times 1 times 20 is 80. So I've got 144 minus 80 all over, and then I could do 2 times 1, which is 2. So then I'll do 144 minus 80, and I get 12 plus or minus the square root of 64 all over 2. So this is working out really well, because the square root of 64 we know is 8. So I have 12 plus or minus 8 all over 2. Now notice that they take care of that plus or minus when we square root something, so you don't have to worry about getting those two answers. It's kind of like built into the equation there for you. So this is where I kind of branch off into two different directions, because we have where I'm adding 8 or where I'm subtracting 8. So if I do 12 plus 8, I get 20. 20 divided by 2 is 10, so 10 is one answer. Then I'll do 12 minus 8, which is 4, divided by 2, which is 2. So 10 and 2 are my answers. So then in B, I'm going to take the same first step. Sorry about my little doodle down here. I am going to get this into standard form. So I'm going to subtract 7 to the other side to get x squared minus 6x minus 7 is equal to 0. And I'm going to put my equation off to the side. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now let's plug in my numbers. Remember, this is a, b, and c. So I take the opposite of b, so that makes it 6, plus or minus the square root of, now b by itself is actually negative 6. And notice how I'm putting it in parentheses. So negative 6 squared minus 4, a is 1, and c is negative 7, all over 2a. So now I'm going to reduce what's in the radical symbol. So I've got 6 plus or minus the square root of, okay, I know negative 6 squared is 36. And then this is an interesting part here is I've got negative 4 times 1 is negative 4 times negative 7 is positive 28. So I'm going to be adding 28, okay, all over, oh, and I just realized I put 2a, whoops, that would have been really 2 times 1, I apologize. So my denominator is 2. So then I'll go ahead and do 36 plus 28, and that's going to give me 64 again. That's convenient, all over 2. So here, and then I know that the square root of 64 is 8. And then here's where I branch off into 2 different directions. One where I'm adding, one where I'm subtracting. So 6 plus 8 is 14, divided by 2 is 7. And then 6 minus 8 is negative 2, divided by 2 is negative 1. So why don't you try number 1 on your own, and remember to get it into standard form first. So when getting this into standard form, your equation should have looked like 2x squared plus 9x minus 18 is equal to 0. And then plugging it into your equation would be negative 9 plus or minus the square root of 9 squared minus 4 times a times c, all over 2 times your a value, which is 2. And then slowly simplify that to negative 9 plus or minus the square root of 81 plus, what is that, 144, all over 4. So then 81, let's see, let me do negative 9 plus or minus the square root of, and then 81 plus 144 gives me 225, all over 4. And I know that the square root of 225 is 15. And then here's where I split into 2 different directions. One where I'm adding, one where I'm subtracting. So negative 9 plus 15 is positive 6. 6 divided by 4 is 1.5. And then negative 9 minus 15, that's going to give me negative 24. Divided by 4 is negative 6. So 1.5 and negative 6 are my answers. So looking at number 2, try that one on your own as well, and then check back to see if you have the same answer as me. So I would have started with, it's already in standard form, so I can go ahead and just go opposite of b plus or minus the square root of b squared, or 14 squared, minus 4 times my a value times my c value, all over 2 times my a value of 1. So then I'll simplify this, so negative 14 plus or minus, well, I know that 14 squared is 196, and then 4 times 1 times 40 is 160, all divided by 2. Oops. And then I will write, let's see, how to do that. So I'll do negative 14 plus or minus the square root of 196 minus 160. That's going to give me 36, all divided by 2. I know that the square root of 36 is 6. And then here's where I branch off into 2 different directions, where I'm adding and where I'm subtracting. So negative 14 plus 6 would be negative 8 divided by 2, which is negative 4. And then I'll subtract. Negative 14 minus 6 is negative 20. Divided by 2 is negative 10. So then number 3 and 4, I am going to do this just to shorten this video. If you feel that you would like the extra practice and you just want to try and see if you can do it without my help, I will tell you that the answers for number 3 are 1 and 2/3. But I'm not going to show you the work. So if you have a question about number 3 and you're not sure why you're getting it wrong, feel free to ask me in class. And then number 4, again, I'm not going to show my work, but I will tell you that your answers are -1 and 1/3. Now the last 2 problems I want to wrap up this video are for 5 and 6, because you're not necessarily going to end with perfect numbers. Meaning, like, we've always had perfect square roots, and so it's actually more common to not have perfect square roots. So if I look at number, let's look at, we'll look at number 5. So I would say, okay, the opposite of b plus or minus the square root of b squared, so 5 squared, minus 4 times my a value times my c value, all divided by 2 times a. So that simplifies or reduces to -5 plus or minus the square root of 25 plus 144. Oh, this is going to work out nicely again, all over 6. Okay, so this is going to then be -5 plus or minus the square root of 169 all over 6. And I know I'm kind of intruding into number 6. I apologize. Well, I know that the square root of 169 is 13. So here we might have a decimal. So -5, let's see, plus 13 would give me 7. And then 7 divided by 6 is going to be 1.3. So that one we rounded, right? And then -5 minus 13 is -18. Divided by 6 is -3. So in that case, we rounded. But I do want you guys to keep in mind that this is not always a perfect square. And when that's the case, you'll definitely have to round. You won't have to simplify. So then number 6, and because I kind of ran into this number 6's spot, I'm going to kind of erase my answer here. So number 6 is interesting because not only is it not in standard form, so I'd start with moving that into standard form. But let's see how this one works out. So I would do the opposite of b, which is +5, plus or minus b squared, minus 4 times my a times my c, all over 2a, which is 2 times 10. So if I simplify this, this is going to look like 5 plus or minus the square root of 25 plus, 4,000 all over 20. And then that's going to be 5 plus or minus the square root of, I'm getting out of room here, so 4,025. Here's going to be a decimal, all over 20. So, hopefully my calculator here works. Let's see. So the square root of 4,025 is approximately, I don't even know where I'm going to write this. I have it off to the side. So now I've got 5 plus or minus 63.4 all over 20. And so now I can branch it off into the 2 possible answers where I'm adding or subtracting. So what I'll do is I will do, let's do plus first. So I'll do 5 plus 63.4. That gives me 68.4 divided by 20, and I get approximately 3.4. And then I'll do 5 minus 63.4, divide that by 20, and I get approximately -2.9. So that's a great example of how that square root isn't perfect, how it's going to look, how it's going to turn out.